On July 15th, 2026, the CN Tower in Toronto, one of the tallest freestanding structures in the world, disappeared. Not literally, but photographically, swallowed by a wall of smoke so thick that Toronto briefly registered some of the worst air quality of any major city on the entire planet. Photographs from that day show the tower reduced to a faint gray outline against a sky the color of old newsprint, the kind of image that normally circulates out of cities dealing with industrial pollution crises, not one of North America's wealthiest, most modern metropolitan areas. Toronto residents that week were advised to limit outdoor activity, and the city's air quality index climbed into ranges normally associated with hazardous conditions, the same category used to describe some of the most polluted urban centers on Earth during their worst days. For a city of nearly 3 million people, many of whom had never experienced a wildfire smoke event of this severity firsthand, the sudden loss of visibility across the entire downtown skyline became one of the most visually striking single images of this summer's continental crisis. That smoke had not come from anywhere near Toronto itself. It had traveled south and east from wildfires burning across Ontario, part of a Canadian fire season that, within a matter of weeks, surged from running well below its 10-year average straight past it. At the same time, in the United States, close to 40,000 wildfires had already scorched more than 3.6 million acres, a pace nearly 10,000 fires and roughly 1 million acres ahead of normal for the same point in the season. Both crises were being driven by the exact same thing, a summer-long series of extreme heat domes that has now rotated across nearly the entire continent since late June, breaking temperature records from New Jersey to Nova Scotia to the Canadian prairies, and drying out an enormous, unbroken stretch of North American landscape in the process. This is not a story about one country having a rough fire season. This is a story about an entire continent baking and burning at the same time, and as this video is being made, officials on both sides of the border are saying plainly that it is not over. Today, we are walking through exactly how this heat wave built across the summer, how it fed wildfire crises in both the United States and Canada simultaneously, and why the smoke from one country's fires has become a direct public health problem in the other's biggest cities. Everything here comes from confirmed government data, NASA satellite imagery, and official fire agency reporting on both sides of the border, not speculation. If tracking extreme weather at this scale is something you want to keep doing, subscribing means you catch the next update the moment new numbers come in. Let's start north of the border because Canada's fire season this year tells a genuinely remarkable story of just how fast conditions can shift. Canada's 2026 wildfire season began slowly, and at first, that slow start looked like good news. As of July 7th, the total area burned nationwide sat at less than half the country's 10-year average for that date. Then conditions turned fast. Over the following 10 days, more than 300 new wildfires ignited across the country, and by around July 17th, the total area burned had rocketed past the 10-year average entirely, reaching roughly 2.8 million hectares, close to 6.9 million acres. Ontario absorbed the worst of that surge. By mid-July, nearly 200 wildfires were burning across the province, more than 130 of them concentrated in the northwest region alone, and more than 60 burning entirely out of control. Provincial fire managers described conditions producing what they called extreme fire behavior, forcing crews to abandon direct suppression attempts on multiple active fires simply because it was no longer safe to fight them head-on. Abandoning direct suppression is not a decision fire agencies make lightly, and it signals a genuinely severe escalation in fire behavior. Crews typically shift away from attacking a fire's edge directly and toward indirect strategies, building containment lines well ahead of the fire's projected path, rather than working close to active flames. Specifically when a fire is producing conditions too dangerous or too fast-moving for firefighters to safely approach. Extreme rates of spread, unpredictable wind-driven direction changes, or fire behavior generating its own localized weather patterns. Northwest Ontario's fire districts, including Nipigon, Sioux Lookout, Red Lake, Dryden, and Fort Francis, absorbed the brunt of that escalation, forcing a broader regional shift toward exactly this kind of defensive, indirect strategy across multiple simultaneous incidents rather than a single isolated fire. Fires were also burning simultaneously in Quebec, British Columbia, the Northwest. Territories, Manitoba, and Nova Scotia, where a wildfire near Moosland Road, roughly 60 miles northeast of Halifax, became one of several new ignitions in Atlantic Canada during the same stretch. Season. The human cost behind a season that, as of the most recent government update, had already produced close to 800 active wildfires nationwide, 60 of them still classified as out of control, even with a full firefighting response underway. On July 13th, the crisis crossed the border directly. Wildfires exploded simultaneously in far northern Minnesota and western Ontario, a shared border ignition event that sent thick smoke pouring across the skies of North America over the following days. That smoke did not stay confined to rural Canada. It billowed south and east, blanketing major population centers including Toronto, Boston, and New York City in thick haze, and on the worst days, some of those cities registered among the most polluted air anywhere in the world. A genuinely startling designation for cities not typically associated with hazardous wildfire smoke exposure. NASA satellite imagery captured the smoke plume streaming southeast from the Ontario. Fires on July 14th, visible from orbit as a distinct continent-scale haze, extending across the Great Lakes region and into the northeastern United States. That kind of orbital view matters because it captures something ground-level news coverage often cannot. The sheer, unbroken scale of a single smoke event stretching across an international border and multiple states and provinces at once. Satellite instruments tracking the plume showed it maintaining a coherent, trackable shape for hundreds of miles, rather than dispersing into scattered, disconnected haze. Direct visual confirmation that a fire crisis unfolding in remote Ontario forest land was, within roughly 24 hours, a measurable air quality event for tens of millions of people living nowhere near an active flame. The scale of this year's disruption prompted a direct diplomatic response, with American officials, including the Environmental Protection Agency, publicly urging Canadian counterparts to extinguish the fires as quickly as possible, and coordinated engagement between Ottawa and Washington, specifically focused on managing the cross-border smoke impact. That kind of direct public diplomatic exchange over wildfire smoke reflects just how significant the cross-border impact has become in recent years, moving what was once treated as a purely domestic environmental issue into the realm of active international coordination. Wildfire smoke does not require a passport or recognize a national boundary, and Canada's vast, sparsely populated northern forests mean that fires burning far from any major population center within Canada itself can still generate smoke plumes that travel hundreds of miles south and directly degrade air quality in some of the largest cities in the United States. Exactly the dynamic that played out as smoke from Ontario and Minnesota, fires settled over the Northeast. Canadian officials, for their part, have pointed to the sheer scale and remoteness of many of the affected fire zones. Several of the hardest hit districts sit in terrain difficult to access even under normal conditions, as a genuine constraint on how quickly firefighting resources can be brought to bear, regardless of the urgency expressed by officials south of the border. This was not an isolated bad year appearing out of nowhere either, and Canadian fire scientists have been direct about the broader pattern this season fits into. The 6 most active wildfire years in Canada's entire historical record have all occurred within just the past decade, and more total land area burned across the country between 2017 and 2025 than during the entire remainder of the historical record combined. The years 2023, 2024, and 2025 were each severe fire years in their own right, the first time 3 consecutive severe seasons had ever been recorded. One fire scientist studying the pattern described 2026 as a genuine test of whether that streak would continue or break, framing the underlying question directly, whether Canada should now expect an active fire season like this one, essentially every year, going forward because of how much the country's climate baseline has already shifted. His blunt summary of where that trend leads: the future is hot and smoky. That kind of streak, 3, and now potentially 4, consecutive severe fire years, matters enormously for how forests actually recover between events. A single severe fire season followed by several quieter years gives burned landscapes real time to regenerate and gives fire agencies breathing room to rebuild equipment and retrain crews and restock budgets before the next major test arrives. A pattern of consecutive severe seasons denies the landscape that recovery window entirely, meaning each new fire season increasingly burns through forest that is not fully regrown since the last one, while simultaneously testing firefighting agencies that have had less time than usual to recover their own capacity between deployments. Canadian fire researchers have been explicit that this compounding effect, not any single fire season in isolation, is what concerns them most about the multi-year pattern the country has now experienced. Now look south of the border, because the United States was experiencing its own version of the exact same underlying pattern at the exact same time, driven by the same rotating series of heat domes. Since late June, a sequence of high-pressure ridges has moved across North America, each one trapping heat against the ground for days or weeks at a stretch and breaking temperature records as it went. The first major dome peaked around the 4th of July, when Atlantic City, New Jersey hit 106 degrees, one of the most extreme single-day readings recorded anywhere in the eastern United States all summer, while the same underlying system brought extreme heat and severe flooding to Canada on Canada Day itself. Severe thunderstorms finally broke that first dome in early July, but not without cost. More than 1.3 million power outages. And 4 fatalities were tied to the storms that broke the heat, along with what may be the largest hailstone ever recorded in the state of Connecticut. The mechanism connecting these heat domes to the fire crisis on both sides of the border is the same one meteorologists point to. Whenever a high-pressure ridge parks itself over a region for an extended stretch, a dome traps sinking air that warms further as it compresses, while simultaneously suppressing the cloud cover that would otherwise reflect some incoming sunlight away from the surface, and it blocks the normal flow of weather systems that would move cooler, wetter air through the region. The longer a dome remains anchored in place, the more completely it dries out the vegetation beneath it, which is exactly why this summer's pattern of rotating, overlapping heat domes, rather than a single, short-lived heat event, has proven so consequential for fire conditions across such an enormous stretch of the continent. A second heat dome built over the western and central United States starting in early July, and has continued reasserting itself in the weeks since, eventually growing into the system that, by early August, stretched from Arizona to Montana, threatening records in Las Vegas and pushing Montana cities like Great Falls and Helena toward marks that, in Billings' case, during an earlier July heat wave, had already been broken outright at 111 degrees, an all-time record for the city. By the National Interagency Fire Center's own mid-July assessment, American fire activity was already running close to 10,000 fires and nearly 1 million acres ahead of the 10-year average for that point in the season, with officials stating plainly that conditions were mirroring what would normally be expected considerably later in the year. Colorado and Utah bore an early, severe share of that activity, including the loss of 3 firefighters and 2 more injured, battling the Knowles fire along the shared state border at the end of June, a tragedy that occurred during what should have still been the ramp-up phase of a typical fire season. That timing matters enormously to fire officials, assessing how dangerous a season is actually shaping up to be. Firefighter fatalities concentrated in the season's earliest weeks, rather than spread across a more typical calendar, are treated as a serious early warning sign precisely because crews, aircraft, and incident management teams are generally still building up to full seasonal capacity during that window. A fire producing fatal conditions in late June, before national mobilization has fully ramped up, suggests fuel and weather conditions have already reached a danger level, normally exactly the kind of acceleration the National Interagency Fire Center's own midsummer advisory explicitly warned about. By the time August's heat dome settled over the Pacific Northwest specifically, the region had already spiraled into one of its most severe fire seasons in decades, Oregon surpassing its own modern wildfire record at more than 2 million acres burned, and Washington fighting more than a dozen major fires simultaneously under its own statewide emergency declaration, including the Sinlahaken fire, which crossed the 100,000-acre megafire threshold while containment remained in the single digits, and the Kaiser Canyon fire, burning at well over 130,000 acres on the Colville Reservation. Put the two countries' numbers side by side, and the continental scale of what has actually happened this summer becomes genuinely difficult to overstate. Tens of thousands of individual wildfires, millions of acres burned on both sides of a shared border. Smoke plumes crossing that same border in both directions, with Canadian fires blanketing major American cities in some of the worst air quality on the planet, while American wildfire smoke has, at other points this summer, drifted north into Canadian communities as well. Nearly the entire continent, from the Arctic-adjacent forests of the Northwest Territories down through the American Southwest, has spent this summer under some combination of record heat, deepening drought, and active wildfire smoke. All of it traceable back to the same interlocking set of atmospheric conditions, rather than a series of unrelated, coincidental regional disasters. Consider the sheer geographic span that single sentence actually covers. The Northwest Territories sit well above the Arctic. Circle in places, a region most people picture as permanently frozen tundra rather than active wildfire country. The American Southwest, by contrast, includes some of the hottest, driest desert terrain on the continent, even in an ordinary year. A single summer connecting meaningful fire and heat impacts across that entire north-south span, roughly 3,000 miles from the northernmost affected fire district to the southernmost heat dome city, is not a coincidence of unrelated regional weather patterns lining up by chance. It reflects a genuinely continental-scale atmospheric pattern, the same rotating high-pressure system reasserting itself throughout the summer, rather than dozens of separate, disconnected local weather stories that simply happen to occur in the same year. The connection between the heat and the fire is not incidental, it is mechanical, and scientists studying both crises describe the same underlying chain reaction driving results on both sides of the border. Sustained periods of high pressure produce extended heat waves. Extended heat waves accelerate the drying of vegetation across enormous areas simultaneously, and that dried vegetation becomes the fuel that turns an ordinary lightning strike or human-caused spark into an explosive, fast-moving wildfire rather than a fire cruise can contain quickly. Canada's own government forecasters, looking ahead from their July update, pointed to exactly this dynamic. Above-average temperatures forecast across much of the country through August, with the driest conditions concentrated specifically in Manitoba and northwestern Ontario, the same regions that had already produced the summer's most severe fire activity. Peak fire danger season in Canada runs through mid-August, meaning, as of this recording, the season genuinely had not yet reached its statistical peak, even after everything already described here. That timing detail is worth sitting with, since so much of what has already happened this summer, the Toronto haze, the Ontario evacuations, the record American heat from coast to coast, occurred before either country's fire season reached the point. Officials themselves consider its most dangerous stretch. Whatever comes next in the weeks between now and whenever autumn rain finally breaks this pattern across the continent is happening on top of an already record-setting summer rather than as a separate later chapter. If you live anywhere on this continent, in either country, here is what is actually worth doing with this information right now. Monitor air quality directly through resources like AirNow or Canada's equivalent air quality index, especially if you live in a major city that has already experienced smoke-driven pollution spikes this summer, since wildfire smoke can travel effectively across enormous distances and affect populations far removed from any actual fire risk. Take extended heat warnings seriously as a compounding risk, not a single-day inconvenience, since the same conditions producing dangerous air quality are frequently the same conditions producing dangerous heat at the same time. If you live in a wildfire-prone region on either side of the border, treat this summer's pattern, repeated heat domes building on top of an already drying landscape, as a direct signal to review evacuation plans and defensible space around your home now, rather than waiting for a specific fire to threaten your community directly. And follow official cross-border resources, including the Canadian Wildland Fire Information System and the U.S. National Interagency Fire Center, since both agencies are tracking a genuinely fast-moving, still developing continental situation together. If you live in a major city that has never previously dealt with significant wildfire smoke, this summer is a reasonable prompt to prepare for the possibility, regardless of how far you sit from the nearest active fire. Keep a supply of N95 or KN95 masks on hand, since ordinary cloth or surgical masks do not effectively filter the fine particulate matter that makes wildfire smoke genuinely hazardous to breathe. Know how to quickly check your specific address's real-time air quality rather than relying on a general regional forecast, since air quality during a smoke event can vary significantly block to block depending on very local wind patterns. And if you have children, elderly family members, or anyone with existing respiratory conditions in your household, have a plan for staying indoors with windows sealed and, ideally, a portable air purifier running, since smoke events that once might have been considered a distant, rare inconvenience for cities like Toronto and New York are increasingly becoming a recurring feature of the summer calendar. What has happened across North America this summer is not two separate national stories that happen to be occurring at the same time. It is a single continent-scale weather and fire event, driven by the same rotating heat domes, producing record temperatures from the Gulf Coast to the Canadian Arctic, and feeding wildfire seasons on both sides of the border, severe enough to send smoke thousands of miles from its source and shut down clear skies over some of the largest cities on the continent. Canada's fire season has not yet reached its historical peak. The heat dome currently sitting over the American West shows no clear sign of lifting, and fire scientists studying the pattern are already asking whether this kind of summer, hot and smoky across an entire continent at once, is becoming the new normal rather than a single exceptional year. We will keep tracking this story on both sides of the border as new records, new fire activity, and new smoke advisories come in. If you want those updates the moment they land, subscribing is the way to make sure you do not miss them. And if you have experienced this summer's smoke or heat firsthand, whether in the United States or Canada, tell us in the comments what conditions have actually been like where you live. Because a satellite image of smoke covering half a continent is one thing, and breathing it is something else entirely, something millions of people on both sides of this border have now had to do for weeks at a stretch this summer alone. Stay safe, and we will see you in the next one.